Okay, so 5.2b, day 2 of integrals. So this is like our more serious day of integrals. We talked about long division of polynomials. So we did this one together, and then we did this one together. And then here is the complete solution for C. So you can tell I made mistakes, just like sometimes you make mistakes. So our final answer was that. I would say the big thing, again, that some people like to do is that, you know, when you subtract, what we do, I don't know why, but what we do, I do know why. But when we see these, we want to automatically add them together. So what some people do is instead of just put a minus here, where I sometimes make a mistake too, they put a minus and then they change this to a plus. And then they put a minus and change this into a plus. They put a minus, change this into a plus. So for like this one, they would put maybe like a plus here and a plus here. For this one, they would put a minus and change this into a minus. And that way you can just add it down. So if you feel like you're making mistakes when you're subtracting, then just go ahead and change your signs and then add down instead of, you know, subtracting kind of in your head, okay? So there's C. And then we talked about this full problem, but let me explain it one more time just in case, okay? So long division, again, I'm sorry it was so fuzzy on your paper. So long division, when the top degree is the same as the bottom degree, or when the top is greater than the bottom, we have to do long division of polynomials, okay? If you try to do it in either way, like if you tried to do, natural log for this one, then you would do natural log, and then in your box, you would actually get an x, and that's not true. So in our box, we never actually want a variable, okay? So for this one, you do long division, so x divided by x plus 4, so x divided by that goes one time, and I write this over again, I subtract, and I get a negative 4. So I have a 1 minus 4 over, so that's my remainder, sorry, and then over x plus 4. So this quantity, I should really have parentheses. So this quantity is my new integral, but it's the same thing. It's just been divided so that I can have two terms instead of one term that I don't know how to work with. Now that I have two terms, what is the antiderivative of 1? Okay, that came from x, that's no problem. What about this? So this is a minus, I'm going to bring down the minus. And then this is, because it's basically a 1 over x, it's like a number over x, it's going to be a natural log. So you take the natural log of the absolute value of x plus 4, and then we don't know what number this is. It could be 4, but let's see, okay? So we're going to take the derivative of this, the derivative of a natural log, a box times a natural log is box, and then natural log derivative is 1 over x plus 4 times the derivative of x plus 4, which is 1. We set that equal to OG right here, 4 over x plus 4. So the OG term was this one, so we set that equal to that. And then cross, cross, they multiply away, box equals 4. Now this is the same as this, I just rewrote it with a 4 instead of a box. There you go. Okay, so I started this one with you. And then, wait, did I start it with you? I don't remember. I think I started with you, but you're going to do your long division, and then hopefully you get this new, right here we have this new integral, but now it's 3 terms instead of this thing that we don't know how to work with, okay? So we have 3 terms. I think from here you can actually do this one in your head, right? I think you can. What did this come from? An x squared. What did this come from? A 6x. So the last one is a natural log, right? So 19 times the natural log. So if you took the derivative of this, don't forget your plus c, if you took your derivative of this, you would get this, which is equivalent to this, technically. All right? Okay, so there's number 2. You check your answer. Number 3 and 4, I think we fully did the Big Brother case, but basically what we're doing for Big Brother is we're trying to figure out, let's say you have something like this. Obviously, you're not going to multiply that out like you did the other day for homework, right? And this one, you can't even multiply it out. So instead of a product rule, like instead of a product rule here, we use Big Brother. So you look at it in terms of this is one thing times another thing. Which one are we going to call Big Brother? Which one are we going to focus on? Okay, sorry, little brother, little sister. There's more focus on the Big Brother. It's just somehow, you know, that does happen sometimes, right? So we call the serious one, the one with more issues, how about that? The Big Brother. So that one I'm going to call Big Bro. And then I'm going to focus on this one. I'm just going to think about this. Where did this come from? Where did a power of 5 come from when you took the derivative? What did it used to be? It used to be a power of 6. So now I'm going to take the derivative. So we worked this out already, and I'll kind of show you my work for it. But you take the derivative of what you think it is. And so the 6 comes forward, and then times the box, times blah, 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 to the 5th power, times the derivative inside, which is 4x, equals, where did this come from? This is OG. This is what we're looking for, right? So when you take the derivative of what you think it is, it should be what you have right here is the problem. So then we divide away whatever we can divide away. The x, I think there's the x get divided away, and then you have box equals 1 over 24, and then now this is the same as this, but now I filled in my 1 over 24. If you take the derivative of this, you will get that. Actually, you will get that. Actually, yeah, you'll get that. Okay, if you take the derivative of this, you will get exactly that. Okay, so this one as well, we worked on this one, I think, together, right? So here's our Big Brother. I rewrote it as a fractional exponent just because it's a little bit easier to add 1 to that exponent, and then you realize this is not really a root, it's a power, right? So you add 1, this is our final answer. I need to find my box. You take the derivative of this, so 3/2 comes forward, times box, times blah, 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 to the 1/2 power times the derivative of the inside, which is 2x, equals. Set that equal to OG problem right here, that OG term. So set it equal and then divide away everything that can be divided away. You get box equals 4 over 3. And then this is the same except a box is now 4 over 3. So final answer, notice that plus c, don't forget about that plus c. Okay, so on the back we started all of these but we didn't finish them. So we're gonna go ahead and check them. So we started these. And then I said, okay, now go ahead and, you know, find the derivative. So you found the derivative, you set it equal to OG problem, and then you solve for your box. Box equals 2, final answer. So hopefully yours matches. And then for number 6, I'm just gonna, you know, yeah, you can do the box method, but eventually you're gonna get that, right? So I'm gonna say y equals. How about that? Y equals, because you can pretty much tell when you find the derivative of e to the sine of x, it's e to the sine of x times the derivative of the sine of x, which is cosine of x. So the derivative of this is literally just that, right? And then you have your plus c. Don't forget about the plus c. Okay. For this one, we did the first step together. I said find the derivative. So you find the derivative. You set it equal to the original OG. And then you solve for your box and then final answer. So check that final answer for yours. Okay. So this one apparently I did not underline. So there's our Big Brother. And this is a little bit different. So remember this one we rewrote as cosine of x squared. So really, oh, I rewrote it here. There you go. So I rewrote it here. So then I underlined my Big Brother. I'll label it. And then now we have that, because if it's a squared here, what did it used to be? You find the derivative of this, and you get that. You set it equal to the original, which is right here. Or you can set it equal to that. Those are the same, right? And then you divide away whatever you can divide away. You get box equals negative 4 over 3. Okay. And then let's see, this one I changed a little bit. Sometimes I change it from, you know, one day to the next. So this one, you're splitting it up and you're realizing this is actually a 3 over x. If you want to put the 3 over here, it'll work the same way. You'll get the same answer, okay? So I split it up into 3 over x and then 1 over ln x. 1 over ln x is my Big Brother. So when you have 1 over, what's the antiderivative? It's going to be box ln and then the absolute value of whatever's down there, right? So ln x. Okay, so now, this one's a little tricky. You're going to find the derivative of this. So what's the derivative of this? Okay, the derivative of box ln of something is box on top and then 1 over this. So then here's my derivative right here. So box over this times the derivative of down here, which is 1 over x. I set that equal to the original. You can use either one. This is an original too. You set that equal to the OG, the original. You solve for your box, and I didn't write it in, and my box equals 3, right? Because these two divide away, the x's divide away, my box equals 3. So that's number 9. And then number 10, I think I started this with you, and we said that was an ln, right? Box ln, 1 plus sine of x in absolute values. And then that's actually just the final answer. When you find your box, the box equals 1. Because what do you get when you take the natural log of this? You get 1 over 1 plus sine of x times the derivative of this, which is 0 plus cosine. So when you multiply by cosine, see how there's a cosine on top? So if you get the derivative of this, you do get that exactly. Okay? Okay, the last two we did together, but oh, I forgot. 4th period, we did not get to finish that last problem. So here's the last two. So we said for this one, it's very, very, very helpful to split it up, because if you try to just do Big Brother, it's not going to work. So sometimes you'll try something and it doesn't work. And that's okay, you'll try something else. So then you split it up. And then somebody was like, Miss Tan, is that a rule? I was like, no, it's not a rule. So sine over cosine is tangent, and then you have 1 over cosine, right? 1 over cosine is secant. And then this is secant squared, and then you think, what gives me the derivative that is that? Oh, it's secant. What gives me this derivative? Well, it's that. So sometimes it's a little bit different, right? So it's a little bit different than like Big Brother or whatever. Sometimes you have to simplify first. It doesn't seem so simple, but it actually is simple when you get to the end. Okay, so here's the last one. So we circled the bottom as Big Brother, but really, when you circle the bottom, you're talking about a 1 over, because this is sine x times 1 over cosine x. So the 1 over cosine x becomes this. So this is our answer, but we need to find what the box is. So you take the derivative. The derivative of this is, so it's going to be box over cosine x times the derivative of cosine, which is negative sine. You set that equal to the original OG, and then cross cross, your box equals -1, final answer. There you go. All right. Oh, sorry, ignore that. I don't know why that's there. So there is the final answer of those notes. So good job today. And then ask me if you have questions, but definitely try those two. All right, try your best. Put your questions in the homework helpline. On Monday, I know you're not going to have like a regular quiz. I am still thinking about a mini, like maybe a pop quiz or maybe like a mini, we call them mini quizzes now, okay? So I am still thinking about that, just to kind of, just so I can at least test you on like long division and, you know, picking out the Big Brother. Even if you can't quite finish it yet, you're going to try your best on the homework though. Do the homework. This is not the section to not do your homework. If you're lazy, do this homework anyway, okay? Do at least half of it. All right, bye.